Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class, I'm going to be showing you a pre-built power relay for your Arduino projects that allow you to turn standard American appliances on or off. So this is a really nifty, neat-o little device here, and I'm very excited about it. Basically, what you can do is you can connect this to your Arduino, or really your Raspberry Pi, any type of IoT type processor, and you can use that device in order to be able to turn on and off power switches, and so we're going to be showing you how this works today. So the warning for today is almost kind of sort of a reverse warning. As in, there are other ways to accomplish the goal of basically being able to turn your appliances on or off, but I would argue those are actually more dangerous ways of doing it, and this is a nice, safer way of doing things. So one of the problems I have as an instructor, especially when I'm talking to the great unwashed masses and I have absolutely no idea what your technical skill set is whenever we start dealing with high power devices. This is when we're talking about actual fans, real lights, dehumidifiers, air conditioners, that type of thing, right? There's enough electricity running through those devices to really hurt somebody, to kill somebody, to start a fire. A whole bunch of bad things can happen, right? So if I'm showing you how to use a standard power relay, so there's a bunch of power relays out there. They all cost about $5 a piece, and you can sit there and you can wire everything together. But the problem is if you wire everything together wrong, and then you turn it on, very bad things might happen, right? You know, you're dealing with real electricity. So if you wire things wrong, or if you don't cover it up and maybe something falls on it and the circuit shorts, something like that, really bad things can happen. So one of the problems that I've been dealing with as an instructor is I want to be able to show you how to do things, but I want to show you in ways that you're most likely not going to kill yourself. I mean, it's still power, to be clear. It's still a lot of electricity going through this thing. But you're less likely to kill yourself, right? And so that's where it's been really frustrating for me. I've been looking at all these power relays, and then when I think about actually using them in a class, again, there's a difference between what I would feel comfortable using myself and, again, teaching people that might be 13 or 14 years old or may just not quite understand what's going on, and then bad things can happen. So what's really cool about this particular device is it's all pre-built. It's all up to standards. So basically what you can do is you can simply plug your little Arduino project directly into this thing and away you go. More or less, you don't have to worry about fire. More or less, you don't have to worry about killing yourself, so on and so forth. But that's why I'm showing you this today. So this thing, when you buy it on Amazon, it's going to cost you anywhere between $27 to, let's say, about $32. So I know a lot of people out there, again, they're all trying to save money off of everything. Why should I buy this for, let's say, $30 when I can buy just a power relay for $5? And really, the reason is because this is pre-built. You literally pull this out of the box, you plug it into your Arduino project, and away you go. You don't have to worry about grounding things. You don't have to worry about coming up with a case for it. You don't have to worry about protecting it, so on and so forth. Basically, this is as safe as a surge protector. Just like you would pull a surge protector out of a box, plug it into the wall, that's the same with this. So it's kind of a reverse warning. The reason that I'm showing you this today, and the reason that I'm so excited about this is the type of thing you can just pull out of the box and you can use, especially when you're dealing with high power devices. That is very significant. Again, when you're dealing with little Arduino, you're dealing with 12 volts, 0.5 amps. I don't want to say what the worst case scenario is. The worst case scenario is probably not bad. If you screw something up with this, you're dealing with basically a 9-volt battery. You might get a little shock. Maybe if you do something really stupid, like truly stupid, maybe you have to go to the doctor. Not even the hospital. You might have to go to the doctor. Again, when you're dealing with high power, if you do something stupid, you may not make it to the hospital. You may just go directly to the morgue. So what I like about this is you can just pull it out of the box and you can just use it. So this thing is so ridiculously simple. It actually takes longer to tell you why you should buy one of these versus how to actually use one once you've gotten it. So let's go over to the workbench. I'll show you what the different ports are on this thing. Then I'll show you the Arduino code I uploaded to one of my Arduinos, basically a little temperature sensor app. And then I will show you how it works in the real world. And so you have an idea why this thing is so cool. So here's what the relay looks like when you get it. Comes in a nice little box. You get your relay that is built very well, and then you get your power cable. Now, really, if I was going to do a review, if I was reviewing, I'm not reviewing. I am simply showing you what exists. You decide what you will do with it, right? But if I was going to review, the one thing that I would complain about is this power cord. This is literally a 2-foot power cord, which means it's just simply not very long. It literally, in order to even do like the demonstration today, I had to go find a different power cord just so that it would be long enough that I could plug it into the surge protector below my desk. So really my only complaint with this thing at all is the power cord. So if you do buy this, realize you may need to grab one out of your parts bin or something like that. The good thing with power cord though is it's just a normal 3-prong connector. So I'm sure you have cords from old desktop PCs or whatever laying around, so you'll probably just need to steal one of those. When we take a look at the IoT Relay itself, again, it is built very well. It's nice hard plastic. Fit and finish is very nice on it. The only thing from a quality standpoint that I would complain about is the stickers need a little bit more glue. Like, the stickers look fine. Like, they're normal yellow and black. They look like very utility stickers. But for some reason, at least on mine, they need some extra glue. Just pay an extra 5 cents to make sure these damn things are glued down. But otherwise, the fit and finish of this thing, this is something that I would put into my server room or I would put into my client's facility, and I would feel good about it. It doesn't feel like some, Chinese garbage like you see some places. So anyways, again, in order to plug this in, you've got the 3-prong power connector here. And then down on the side here, this is the connector that allows you to plug this into your Arduino, your Raspberry Pi, or whatever your IoT compute is. Basically, all this is a positive and a ground. So essentially, when your IoT device starts sending power through the positive, that then turns a switch on in the relay, and then when that switch is turned on in the relay, the circuit is connected to have ports turn on and ports turn off. So that's basically how that works. When we take a look at it up here, again, you've got a little power reset switch here, and then we have the 3 power ports. Now, it is important you understand how these power ports work, because when you first look at this, when I first looked at it, I was hoping it was something. Remember, just because you hope something is something doesn't mean it is that thing. So when you see 4 power connectors and you see this connector, you're like, ooh, you have the idea that you'll be able to control all 4 power connectors. And that simply is not the case. It is not the case. Basically, you only have the ability to do one on or off. And so it's important to understand how that works if you're going to purchase this particular relay. So the first power connector here is simply always on. So this is the always on connector. So this is what you most likely plug your Arduino or your Raspberry Pi device into, so that device is always getting power. Then what you have over here, these are the normally off. So these 2 ports here are normally off. They're on the exact same circuit. So they're in the exact same circuit. If one is off, they're both off. If one is on, they're both on. So when the switch signal comes in, both of these turn on, both of these turn off. The curious thing about this, though, is actually all 3 of these ports are on the same circuit. This one, though, is normally on. So basically, this is normally on. These 2 are normally off. When a signal comes in, these 2 get turned on, and this one gets turned off. So it's important to understand that these 3 are actually on the same circuit. The difference is this is normally on, these 2 are normally off. When the signal comes in, these get turned on, this one gets turned off. So this is something to be thinking about with your particular project, what you plan to do. So let's say you're going to be having some kind of ventilation system. So let's say you have a little warehouse, or you have some kind of, let's say, a server room or something. And so you always need some type of ventilation on. But if, let's say, it gets too hot, you need a bigger blower fan to turn on. So what you could have is a small fan plugged into the normally on. So, if it's under 80 degrees, this one's normally on, and so you got a small fan going. And then if the temperature gets above a certain level, what you can have is the small fan will turn off and then the big fan will turn on. Or let's say, again, let's say in an HVAC, let's say you're dealing with a server room. Let's say most of the time, a fan is all you need in order to cool the server room. So normally on, so the fan is on, and then let's say the temperature gets above 80 degrees. At that point, you have the fan turn off and an air conditioner unit turn on. So you don't necessarily want a vent or a blower fan on when your air conditioning is on. So what you could do is you could have the fan on normally, and then when it gets above 80 degrees or whatever the temperature is, the fan will turn off and your air conditioners will turn on. And so it's just important to understand how this works. So with these two ports here, again, you send the signal in, normally they're off, they'll turn on. With this one here, it's normally on, and when the signal comes through, it will turn off. So there's only one circuit, and so these are simply controlled in reverse with that. And so that's basically how that works. So with that, let's go over, take a look at the Arduino code I created. Basically, I just created a little temperature project, and then I'll show you how it all comes together. So this is basically the stock standard project I use whenever I'm trying to demonstrate different interactive features with Arduino projects. Basically all this is this is just a simple temperature application. And what I'm doing with this particular temperature application is what I'm going to be saying is if the temperature is above 80 degrees Fahrenheit, then I'm going to turn the power pin on. So that's going to turn to high. If it's below that, so else, if it's under a temperature of 80 degrees, we are going to turn the power pin off. So that's all we're going to be doing. If we go up, we take a look at this. Again, since this is an analog temperature device, we have the sensor pin is to A5. The power pin, all we need here is a power pin is to pin 7. You will notice for Arduinos, there are no additional libraries. There's nothing else here. Literally, in order to get this relay to work, all you have to do is basically feed it power. So what we're going to do is when we turn on pin 7, that will send power to the relay. That will turn the ports that are normally off on, and the one port that's normally on to off. Void setup, so then here we do pin mode, power pin that we defined up here, and we're going to set it to output. So again, so we can send the power out. We come down here, again, this is the stock standard for how to determine temperature with an analog temperature sensor in the Arduino. Use this a lot of times. I'm simply doing here serial.println, the temperature Fahrenheit. This is so I can see what's going on in the serial monitor, make sure everything's working properly. And then all we have down here again is the simple if-else statement. If temperature temperature Fahrenheit is above 80 degrees, turn the power pin on to high. Else, if it's under 80 degrees, turn the power pin low to off. Delay 1 second and loop, loop, loop. So with that, let's actually take a look at how this works. Okay, so now we have a bit of a mess. We have a bit of a mess, but it all makes sense, I swear. So basically right here, you're seeing a little serial monitor readout from my little Arduino device. And so the Arduino device is now showing that it's detecting the temperature is about 64 degrees, right? Then past that, basically we have our Arduino device, pin 7. So pin 7 is plugged into the positive side of the little green input. And then the ground is then plugged into the ground side of the little green input. And so that's all you need to do to connect the Arduino to this IoT relay. Again, that's one of the things that's nice. You don't need any additional libraries. You don't need anything sophisticated. You just power on whatever digital pin you want to power on. You connect the wires, and then that's it. From that point, we have 3 different basically lights connected to this IoT relay. So this light here, this light is always on. So this, again, this is going to be the port that you would plug your Arduino device into, or basically what needs to be on 24/7. Now you'll notice this light here, this light is plugged into the normally on port. So this port is normally on. So again, right now, we don't have any signal coming in, so it's normally on. This light over here that's currently off, this goes into the normally off, right? So basically these 2 power outlets here are normally off, and as you can see, it is currently off. So if there is no signal coming in from the Arduino device, this one will normally be on, this one will normally be off, and frankly, this one doesn't care. It will always be on. So at this point, then what I'm going to do is I'm just going to come down here, I'm going to grab the little temperature sensor, and the temperature is now up to 70 degrees, 72, 74, 75. So it's slowly ticking up. And then when it does finally tick up, finally, come on, gets above that 80 degrees, we're going to see that one. So this one has now turned on. So the normally off is now on because it's getting a signal. The normally on bulb, though, has now turned off. So do you realize these always work in reverse? So one that's normally on will turn off. The ones that are normally off will turn on. And again, the one that is always on will simply always be on. I simply take my finger off, I allow the temperature to drop again, and we see that this light, the normally on light, comes back on, and the normally off light then turns off. And that's all there is to basically how this works. Again, you could plug a fan into this, you could plug a dehumidifier into this, you could plug an air conditioning system into this, you could plug a power pump. Basically, again, anything. Anything that's going to be using 110, so any standard American power device, you could be able to plug into this, and basically it's that easy to get it to work. So if you are interested in this, you can go to DLIdirect.com, Digital Loggers Inc. These are the folks that actually build this thing. And as you can see, that they sell this currently for $26.95, and you can get some more technical information about it here. Past that, as always, you can buy it on Amazon.com. It is weird. I don't really understand what the pricing and everything on Amazon. So you'll see this is by DLI, but you'll see it's $32 here. So directly off of their site, it's $27. Here, it's $32, and it says DLI. But the weird part is, if you come down here to the new or used, and you click on this, what you'll notice is for here at $27, you can actually buy this directly from Digital Loggers Direct. So just realize whenever you do decide to buy this thing, if you're interested in buying it, look around at the prices and decide where you're going to buy it from. If you already have an Amazon account, if you buy it from Amazon, just think about going down to the new or used and actually looking at trying to buy it from Digital Loggers Direct, or of course, you just go to their website and buy it. Again, it's that whole Amazon world of you get the same product, but sometimes the price for that product varies dramatically. But DLIdirect.com, or just take a look for it on Amazon. So you know how the tech YouTubers get really excited about things like bezels? Bezels. They'll never shut up about bezels. And you sit there and you look at a screen and you're like, really? Does the bezel matter that much? Well, the same way that most tech YouTubers get excited about bezels is the way I'm excited about this thing. Yeah, I know it doesn't look amazing. I know it's probably not as complex and interactive as you want, but this is going to make my life really, really, really easy, and especially as I try to teach you folks additional classes where we're going to be powering higher power devices. Again, when I'm showing you how to turn a fan on using a 9-volt battery, I'm not that worried. Again, the worst case scenario, you'll go to the doctor. Worst case, you'll go to the doctor, and you have to do something pretty stupid for that to happen. But again, it is important to be thinking about when you're dealing with real dehumidifiers, when you're talking about real power. If you do something wrong, something shorts out, the whole 9 yards, again, you might not make it to the hospital. You might just be dead, right? Again, when I started with the IT world, I started as a U.S. Army electronics repair person, and what can happen to the human body when it gets hit by too much electricity can just be really, 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 really nasty. And so that's why I know a lot of people out there will be saying, like, Eli, I'm just going to go out and buy this little $5 relay. But remember, when you go out and buy those little $5 power relays, technically they work fine. But you're getting a bare device. So the relay's there, all the connections, the soldering, all of that's there. If you do something stupid, like if you put it on the table and you start talking to your mom or something, and you put your hand on it and you use your hand to short out a connector on one of those relays. Like, no, seriously, like, it's bad. So what I love about this is this gives me all the functionality of basically a relay I can control with my IoT device with all of the safety of just a normal surge protector. Now, to be clear, if you do something, you stick a fork in. Still, don't stick a fork in it. But you know what I'm saying? I think the extra, $20 in order to buy something like this, again, for standard projects, or if you're going to be doing things in your own house. Again, think about it if you have kids running around your house. So if you want to create little IoT projects and you have a 5-year-old kid running around your house, do you want some kind of bare Arduino relay sitting there where your kid's like, right? That $20 you saved for that relay might get really expensive. So what I like about this is something I could drop into a client site and not think twice about. This is something I can teach you folks on and not think twice about. This is something that I can put into a normal home environment with kids or whatever else. And, I'm still worried about kids showing forks in it. There's only so much you can do. So this is a really cool device. Just realize though, again, you have the circuit. With the circuit, one of the ports is always on. So one is always on, one's normally on, the other two are normally off. So when the signal comes through, the normally on turns off and the two normally off turn on. Again, as long as you realize that when you buy this and design that into your project, I really don't think you'll have any problems. So anyways, really cool device. Not a review. Don't do reviews. I just show you I am showing you what I purchased and what I used. You, as I say, do you. As always, I enjoy doing this video and look forward to seeing you in the next one. If you like the content that I create, please think about going to eliTheComputerGuy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.